Hi there. In this video, I want to cover the topics of tolerance and slippage. I'll explain what these two words mean and the concepts behind them and how they apply to the pump shop. So first things first, let's talk about tolerance. Um, so in oil and gas pumps, tolerance is talking about how closely can a plunger and a barrel fit together. So obviously by this point you know that plungers fit down inside barrels. Um, of course they need to be a very tight fit, but they can't be too big or they won't fit. So that is your tolerance, is getting them to fit together. And so I'm going to draw you some pictures here to help explain that. So I'm going to start with a barrel. So right there, we have our barrel. Let's see if I can straighten these up just a hair. Okay, so there's our barrel. And when we're talking about tolerance, there's this concept of base. And base is with a new barrel, with a perfectly good new barrel, base is going to be the diameter on the inside of the barrel. So let me just oops, that, and we're going to label this base. Fit? Yeah, there we go. That works. Okay, base. So, and the exact measurement of this will depend on the size of your pump. So if it's an inch and a half pump, usually designated in a pump description as 150, 150, so 150 100ths of an inch, inch and a half. This will be exactly inch and a half. So we'll go ahead and label that as well. Base. Let's just say this is a inch and a half pump. If it was an inch and a quarter or 2 inch, it'd be 125 or 200. But for the purposes of this video, let's just talk about an inch and a half pump. So we're going to label that 150 right there, inch and a half. That is your base. It is exactly that measurement on a good barrel, nothing more, nothing less. So let's talk about the plunger for a second. Let's say I've got a plunger and I need it to fit inside this barrel. And this plunger will also be labeled 150, right? That's the size of this plunger. Now, is it going to be exactly an inch and a half? If it were, it would not fit inside this barrel, right? Because this barrel itself is an inch and a half. If your plunger is also an inch and a half, as it's labeled, it's not going to fit. So there we have the concept of tolerance. And what tolerance is, we make the plunger just a little bit smaller than the barrel. And this is usually given as a number, and it'll usually be something like minus 0.003 is how that will be designated. What that is telling me, if I have a 150 or inch and a half plunger that is minus 0.003, that means it is 3/1000ths of an inch smaller than the measurement given, right? So if it's an inch and a quarter plunger, it's 3/1000ths of an inch smaller than an inch and a quarter. But with our example here, we have an inch and a half plunger. This is 3/1000ths of an inch smaller than an inch and a half. And just that is all it will take. Oops, Control Z that. Just that is all it will take to make this plunger actually fit inside this barrel. 3/1000ths of an inch. Um, so that is our tolerance. This number can be different. It's not always going to be 3. Sometimes it might be a minus 0.002, so that would be 2/1000ths, or even, oops, a minus 0.004, or a minus 0.006 even. So where would you see these different numbers from a minus? I don't think you'd ever see less than 0.002. I think a minus 0.001 would be too tight to fit. 1/1000th just isn't quite enough to get a fit. Um, so minus 0.002 would be the largest plunger you would see. Um, Getting a little bit smaller, 0.004 or even down to 0.006. Um, so where would you see these different plungers? Well, it has to do with the length of the plunger. Usually a 2-foot plunger, you can easily get away with a minus 0.002. There's less surface area. That's a very short plunger, a 1 or a 2-foot plunger. You can easily run a minus 0.002 because it's not real long. You don't have a lot of friction built up from the length of it. You can run a minus 0.002. If you've got a 4-foot plunger, you might run a minus 0.003. If you've got a 6-foot plunger, you may need as much as a minus 0.004 or smaller of a plunger to get it to fit right and for the friction not to be too much, because the longer the plunger you have, the more surface contact it's got, the tighter it's going to feel as you slip it in, so the more tolerance you're going to need. So this number really has to do with the length of the plunger. Um, for our cases, and this won't always be, but we mostly see 2 to 4 foot plungers. We see a lot of 3-foot plungers that are minus 0.002 and minus 0.003 are going to be your most common ones. So I hope that explains. I hope you've got a good idea now of what base is and of what tolerance is. So next, let's talk about the wear on plungers and barrels. So this would be, as I mentioned with the barrel, brand new barrel, nothing wrong with it. It's got the base 150 and no tolerance. It is exactly what it says it is, an inch and a half. And then we have the plunger that is exactly what it says it is, so an inch and a half minus 0.003, minus 3/1000ths of an inch. Brand new, perfectly good. Now, you run those and they run for a while. It's not going to stay that way. They're going to wear down. The plunger is going to get smaller with time, and the barrel is going to get larger with time, right? Because the plunger is moving up and down inside the barrel, it's wearing away at it. At the same time, the plunger is getting smaller in diameter because the barrel is wearing away at it. So you may, after a while, pull this pump and you can mic the barrel and plunger, meaning you can measure their diameters. And you may measure the barrel to then be a plus 00, let's just say plus 0.004 on the barrel. So it's been run for a while and it's now got a plus 0.004. And you measure what was your plus 0, or your minus 0.003 plunger is now a minus 0.005. So you have now gone from where you had a tolerance of 3/1000ths of an inch. Well, now you've got a tolerance of 9/1000ths of an inch. And that may not seem like much, but that's 3 times larger, bigger of a difference than you had intended, because you've got, you had your inch and a half barrel. Well, now it's been worn out, it's a little bit bigger, and your plunger is worn out, it's gotten a little bit smaller in diameter, and there's just a little bit more space. So that's how when we mic barrels and plungers after they've been pulled, that's how we describe them. Barrels get a plus because they've gotten bigger, the inside has gotten bigger in diameter. Plungers get a minus because they've gotten smaller in diameter. Um, so that brings us to the concept of slippage. So what is slippage? As pumps wear, as these diameters increase, as this gap gets bigger, fluid can actually start slipping around the outsides of the plunger, right? So there's a lot of pressure built up. You're trying to move fluid up. There's a lot of pressure built up around your plunger. Well, as these get bigger, fluid can actually slip around your plunger, and that leads to two things. The main being inefficiency. If you're trying to pump this pump and you're trying to move fluid up and fluid just slipping down, back down along the outsides of your plunger, you're not going to move as much fluid as you're supposed to. So the volume the well produces over time will decrease. Well, if you've got a well, perfectly calculated, you figured you need to produce this much volume to produce this well efficiently, and you start losing that volume, you're going to start losing oil because your fluid level will rise and you won't be able to move the water that you need to move to get to the oil. And so the well overall will just not be as productive because of this inefficiency. The other thing it can actually cause is it can do what it's called, it can cut the oil or cause cut oil. And that is this oil and water that has moved in this very tight space under high pressure past this plunger. And it actually changes the molecular structure and bonds the oil to the water. And so then you're going to have cut oil, which is oil that is stuck to water or water that's stuck to oil, and that causes problems for us. That is then a heavier fluid. It sinks in our separators, it sinks in our tanks. The purchasers will detect it and they won't buy the oil. And so cut oil is another problem you get besides the inefficiency of slippage. Cut oil is also a problem you'll have as well. Um, One thing you can do, let's say you've run this pump. I'm gonna erase some of this. Let's say you run this pump and you pull this barrel. I'm gonna pull this out as well. And you mic the barrel and you find it is now a plus 004, but that's only on this side or only in the place. Let's say that the plunger was just stroking in this area up here and it's a plus 004. Well, you might mic it down here and find that it is still at zero. It's still at base. What you can actually do is flip this barrel over so that the bottom end is now on top and rerun it that way. So that's one little cheat you can do if you need to if you want to rerun a barrel, if you're able, because you may not mic it the same all the way through the barrel. It's going to be wider where the plunger is hit, and it's going to be closer towards base where the plunger has not been run. And so a lot of times you can actually flip barrels to overcome this. So fairly simple concepts when you think about it, base and tolerance. Hopefully this explains it. If you've got any questions, please ask your supervisor. We want you obviously to learn this stuff really well and fully understand it. It's going to be necessary for you to work in the pump shop. So any questions that you have about this, please ask. Thanks a lot.